Following notes will go over calculating theoretical reactant, excess reactant, theoretical yield, and percent yield. We first have to begin with the limiting reactant. To calculate the limiting reactant, you have to calculate the amount of product that would be formed if each of the reactants were completely consumed. Think of it as a peanut butter and jelly sandwich, meaning how many peanut butter and jelly sandwiches would I have if I used up all the peanut butter that I had in front of me? How many peanut butter and jelly sandwiches would I make if I used up all the jelly in front of me? And how many peanut butter and jelly sandwiches would I make if I used up all the bread? Assuming you only have a jar of peanut butter, 3 packets of jelly from McDonald's, and a loaf of bread. So that's what you're kind of thinking about. So I have to take each of my reactants and go to the same product to see which produces the least amount. In my example, my product would be my peanut butter and jelly sandwich. So if I have 3 packets of jelly from McDonald's, a whole jar of peanut butter, and a loaf of bread, my jelly would be my limiting reactant. It would only produce 1, probably, peanut butter and jelly sandwich. Where I could produce several peanut butter and jelly sandwiches from a loaf of bread, and several peanut butter and jelly sandwiches from peanut butter had I not have enough jelly. Okay, so you're going to calculate the number of products that would be formed if each of the reactants were completely consumed, using up all the jelly, using up all the peanut butter, how many would I be able to make, and if using up all the bread, how many would I be able to make? Calculate the amount of products for each, that's what we would be doing, so we'd be figuring out how many peanut butter jelly sandwiches would I make from those. And the reactant that produces the least amount of product is the limiting reactant. The other reactant or reactants are the excess reactant or reactants. So, in my example, jelly would be my limiting reactant, peanut butter would be one of my excess reactants, and bread would be my other excess reactants. Please note, in most of the reactions we will do, we only have 2 reactants, therefore there will be 1 excess and 1 limiting. And they have to be a reactant. Remember, reactants on the left side or the beginning side of a reaction. Once you establish the limiting reactant, for any questions about that reaction, you must use the limiting reactant as your starting point. So unless you change the amount you're starting with, you always start with the same limiting reactant for solving every problem within that example. Theoretical yield. Please jot down the definition for theoretical yield. Pause as needed. So theoretical yield is basically what should we get in theory of whatever part of the reaction we're asking about if we started with the limiting reactant. So your theoretical yield is really how much you would get of something, and it can be in moles or grams or volume in most cases. And your limiting reactant is what you start with. So you'd start with your limiting reactant and go to that, and that's in theory, based on the limiting reactant, how much would we get? Percent yield. Percent yield is how much we yield from the reaction. Okay? How accurate or efficient is the reaction. So percent yield is going to be experimental over theoretical times 100. Sometimes the word experimental can be used as the word actual. What did I get in the experiment? What did I actually get in the experiment? That's what you're thinking of when you think of these two terms. Theoretical, remember, has to come from the limiting reactant. So in theory, what should we have gotten had we had any kind whatsoever of experimental or any kind of error, human error whatsoever? So actual or experimental can be used on top, and it's what we actually get in the experiment. Theoretical is using stoichiometry starting with the limiting reactant. Using stoichiometry starting with the limiting reactant, how much of that substance should we get? Divide those two numbers and multiply by 100. We're going to begin with this problem. You'll need a periodic table, a calculator, and something to write with. Of course, the first thing we must do when we use a chemical equation is write the equation if it's not provided and then balance. So in this example, we are going to have zinc metal reacting with, zinc metal is going to react with hydrochloric acid. Let me just get my pen set. So we're going to have zinc. Zinc is by itself, but it's not a diatomic, so it's just zinc plus hydrochloric acid. Hydrochloric acid, hydroics come from ide, so hydrochloric acid comes from chloride. And then we have to figure out what kind of reaction it is. We know it's a single replacement reaction because it's not one of my synthesis or decomp. So zinc's going to try to kick out hydrogen. It can. So zinc goes with chlorine, leaving hydrogen by itself. Zinc and chlorine, how do they go together? Zinc's a +2, chlorine's a -1. So it's going to be ZnCl2. and hydrogen is diatomic, it's H2. If this is still a struggle for you, you should be reaching out for help. Then we need to balance this. I have 1 zinc, 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens. So this is how it would be balanced. This question says how many grams of hydrogen are produced, aka another way I could ask this, a more sophisticated way of asking this would be, what is the theoretical yield of hydrogen? So I can say how many of something I need, or I could talk real chemistry sophistication and say theoretical yield. So how many grams of hydrogen are produced, or what is the theoretical yield of hydrogen? Either way that could be asked. Okay, we have to have a starting point, but we have 2 starting points. We don't know what our limiting reactant is. Up until this example, you were only given 1 starting point, so you had to assume that was a limiting reactant. So we're going to take our 22.34 grams of zinc and our 21.62 grams of hydrochloric acid, and we're going to take them both to the same comparison point. So we can take them to zinc chloride, or we can take it to hydrogen. It doesn't matter which product we go to, technically, but we got to take both starting points to the same comparison point. You got to take both to the same comparison point. So since I'm asking about hydrogen, I might as well go to hydrogen. Sure, I can go to zinc, but then I'd have to do another stoichiometric grid to get to hydrogen. So if it asks you specifically about something, I would use your work to do 2 things: establish the limiting reactant and get you to your answer. So we're going to take zinc and we're going to go from zinc to hydrogen. So first thing I'm going to do is get rid of grams of zinc. I know from the periodic table there are 65.31 grams of zinc, and that is equal to, I'm going to check that on my periodic table, I'm trying to memorize that, up 65.39 grams of zinc for every 1 mole of zinc. This is something you should already know, and if you're struggling with this piece and how this works, please reach out to me. And then I know for my balanced equation, 1 mole of zinc equals 1 mole of H2. This is what I call the mole shuffle. Then I'm going to keep going. And how do I know it's 1 to 1? Well, zinc has a 1 in front of it. Remember, hydrogen has a 1 in front of it. Then I know I have 1 mole of hydrogen for every 2.02 grams of hydrogen. Remember why that's the case? Periodic table, there's 2 of them. And then I'm going to calculate what that answer is. I'm going to use the next slide to do that. Okay, so we're going to figure out the mass here. Take 1 hydrogen, and 1 chlorine, and you should get 36.46 grams of HCl for every 1 mole. 36.46 for every 1 mole of hydrochloric acid. So I use the periodic table, 1 hydrogen and 1 chlorine. Then I know from my balanced equation there are 2 moles of HCl. Remember, it has to cancel. There's my 2 moles for every 1 mole of hydrogen. And I know, like I did up on top, 1 mole of H2 equals 2.02 grams of H2. Okay, so I can calculate. What am I going to do? Multiply numbers across the top, multiply numbers across the bottom, and divide the 2. I like to take the numbers and multiply all the numbers across the top, but then I hit equals on my calculator. Then I take 65.39, for example, and divide it. So I take all these numbers, hit equals, divide by 65.39, hit equals, and then I have an answer. Here I take 2162 times 202, hit equals, divide by 3646, hit equals, divide by 2. So your options are you got a lot of options to figure out how to do this. You can either multiply numbers across top and bottom, divide the 2, or you can multiply numbers across the top and then divide by each number on the bottom, hitting equals in between. What I would suggest you do is make sure that you can get this answer on your calculator right here. Okay, so you can get these 2 answers on here. Okay, so let's go back for just a moment. Let's talk about what we did. What we were doing is we were taking both reactants to the same product, right? We did this to do 2 things: to establish a limiting reactant and to calculate the theoretical yield. So that's the work I was doing here. Okay, walked you through it. We started with 2436 grams here, 2162 grams of hydrochloric acid here. We took them both to hydrogen. So we did this. We took both the reactants to the same product. We went to hydrogen. It'll do 2 things. It'll establish a limiting reactant, and it'll also help us calculate the theoretical yield. Because remember, the theoretical yield must come from the limiting reactant. And here's the work for that. So I know I've already labeled this, but let's talk about this. I took these and I got 0.690. I did the math on this and I got 0.5999. Remember a moment ago I mentioned that you might want to make sure that you can get these answers on your calculators correctly. And I was using sig figs here. 3 sig figs and 3 sig figs. Now, I know we haven't necessarily gone over sig figs again, but that's okay. You can just go through because we'll be doing very free answers here, meaning we'll probably do like either 2 places or 4 places past the decimal. Okay, so off of sig figs, back onto our problem here. So we took this guy and it made 0.690, and hydrochloric acid made 0.599. So this is our least amount of product, right? I'm comparing these two products, same product, but zinc was able to would produce 0.690, and hydrochloric acid would produce 0.599. Therefore, the limiting reactant isn't hydrogen because that's not a reactant. This tells us what the limiting reactant is. Our limiting reactant is hydrochloric acid because hydrochloric acid is one of my reactants. I had 2, zinc and hydrochloric acid, and hydrochloric acid produced the least amount of product. So it is my limiting reactant, therefore resulting in zinc being my excess reactant, meaning I'd have extra zinc left over in my test tube, and all my hydrogen would have been used up, being able to produce 0.599 grams of hydrogen. Okay, let's look at another example. It says how many grams of excess reactant are present? So we're looking for excess reactant this time. Okay, so let's remember for just a moment that this was my limiting reactant and zinc was my excess reactant. Okay, these cannot be limiting or excess reactants because they're products. Okay, so which of these is my limiting? Hydrochloric acid, making by default then zinc my excess reactant. So I'm going to start with my limiting reactant and go to my excess reactant. Remember, your limiting reactant is what starts every single stoichiometric calculation. All the examples I've given you so far, I forced you into starting with the limiting reactant because I only gave you one answer to start. So if you only have one option, you have to assume it's a limiting reactant or no chemistry can occur. So we're going to go from hydrochloric acid to zinc. Okay? And we're going to look back for just a moment at the starting amount of hydrochloric acid. So that's 2162 grams of hydrochloric acid. All right, let's begin this problem. We're going to start with the limiting reactant. So we're going to start with 21.62 grams of hydrochloric acid. And we're going to take this stoichiometrically to zinc. So we already knew this is 36.46 grams of hydrochloric acid for every 1 mole of hydrochloric acid. And we know from our balanced equation there are 2 moles of hydrochloric acid for every 1 mole of zinc. Remember, we're going to zinc. And then I know from the periodic table 1 mole of zinc equals 65.39 grams of zinc. Okay, looked it up on the periodic table. Let me just make sure I hadn't forgotten that. I know it's only been a few minutes. It looks good. Okay, and then we're going to do our math. And we're going to get grams of zinc. Now, stoichiometry gives us 2 things. Stoichiometry tells us how much we used, if we're looking at something on this side, because we're using the reactants, right? Or stoichiometry tells us how much we produced. Used is on the reactant side, produced is on the product side. Okay, so this is how much we used, because we figured out how much zinc we used, starting with my limiting reactant. Okay, so we're going to go through and calculate this math, but we're not done. We have to figure out the excess reactant. That's what's left over. We know how much we used. We don't know how much is in excess or left over. So we're going to have to do a little subtraction. I like to call it the SU. Okay, so we're going to take our starting minus our used to figure out our excess. How much, and it has to be all of the same chemical. This is a key. It has to be all about the same chemical. So how much starting amount of zinc did we have? How much did we use of zinc? Tells us how much is left over. So let's go back and let's see how much zinc we started with. We started with 2234 grams. So we're going to start with 22.34 grams of zinc minus, we got to figure out what this is. That's going to tell us how many grams of zinc are in excess. So SU is a way to help yourself remember what to do when you see the term excess reactant. When you're asking for the excess reactant, you have to SU. Think of SU. Let me show you it in better writing. So we took this through, just like on the last problem. I got 1939 grams of zinc, and then I have to SU. Remember what SU is? It's the start minus used gives us excess. So I did that here. Start, 2234 grams of zinc. If you look back, that's how much zinc we started with. We calculated, starting with our limiting reactant, we went to zinc. We got 1939, we subtracted 2, so our final answer would be 2.95 grams of zinc in excess. That's how much is still in our test tube or left over. Okay, last kind of example that we're going to go over for this set of notes. What is the percent yield if the actual amount of zinc chloride is 3639 grams? Okay, so see words, percent yield, you should write this. So if you see the words percentage yield in any calculation, I would automatically jot down A over T equals percent. You don't have to write this part, but I want you to remember that percent will be written as a decimal. So if you see the words percent yield in any problem, I would write A over T equals percent over to the side of the problem, because you know you're going to have to use this to calculate the problem, to calculate the answer, pardon me. Okay, so we are going to start with the limiting reactant, and we are going to go to zinc chloride. So we're going to start with limiting reactant. Remember what that is, because remember, I have to figure out the A or T or percent. It's asking me for percent yield. So therefore, I have to be given the A or the T. Almost always, the T will be limiting reactant with Stoke. Okay? If we can get the T and we have a percent, we can get the A. Or we have to be given the A. We have to be basically be given or have a way to get 2 of the 3 of these. In this case, we can figure out the theoretical yield because we can start with the limiting reactant. And it gave us the actual amount if you read the word problem. So we actually know this to be 36.39 grams already. Okay, so then we're going to start with the limiting reactant, 21.62 grams of HCl. Because think about what we've done so far. Do we know anything about zinc chloride? A over T must be the same exact chemical. So your A must be the same chemical, your T must be the same chemical. Anytime you figure out a percent yield, your yield must be apples over apples. Same thing over same thing. Very, very, very important. Same thing over same thing. So this has to be both about zinc chloride. Okay, so I got to get to zinc chloride because I don't know how much zinc chloride I've made. All I've figured out so far with my limiting reactant is I figured out how much hydrogen I've made for each, and I figured out in this case how much zinc I used for each. So we're going to have to do another stoichiometric calculation to figure out how much zinc chloride this time. So we're going to take 36.46 grams of HCl from the periodic table for every 1 mole. This is just good old stoichiometry, right? Then I have 2 moles of HCl for every 1 mole of zinc chloride. How do I know to go to zinc chloride? Because where I'm going goes on top, just like we did in the last set of notes. Okay, and I know 1 mole of zinc chloride equals its molar mass. We're going to take 2 chlorines, 35.45, times 2, plus zinc is 65.39, and I get 136.29. So 136.29 grams of zinc chloride. You will notice that I will always count my molar masses to 2 places past the decimal. I will round my molar masses, that's what this is, to 2 places past the decimal always. So now we're going to multiply 2162 times 136.29, divide by 36.46, divide by 2. I'm hitting equals every time, and I get 40.41, 2 places past the decimal, sig fig rules, but in this case 2 places past the decimal, grams of zinc chloride. Now, remember what this tells us. Stoichiometry tells us how much we used or how much we made. This is how much zinc chloride we made. Okay, used if it's a reactant because we're using up reactants, made if it's a product. So we now know our T to be 40.41. So we can divide these two and then figure out our percent. So let's do that. And then I'm going to go to the next slide to show you that in font instead of my handwriting. Okay, so we got 40.41, and now we're going to take A over T. Let's do that. So we're going to take the, in cleaner format, 30, I can't remember what it was, 36.39, divide by 40.41. So 36.39 divide by 40.41. Now we need it in a percent, so we're going to multiply by 100. Okay, and that gets us our percent. So we're going to take this as 90.05% would be our final answer, with 2 places past the decimal, in this case 4 sig figs. So I had to multiply this by 100 to get it into a percent. Okay, so A over T, actual is what we got in the lab. Theoretical you have to get from stoichiometry, starting with the limiting reactant. All right, that concludes our notes for this portion of our unit. Thank you very much. Please reach out if you need some help. I'm here for you.